In this video, I'm going to show you how to create an inventory management agent. We are going to build an agent that is able to process receipt images and update the inventory. As well as the images, it's able to receive voice commands from you and update the inventory as well. Also, when an item runs out of stock, it's able to automatically send an email notification to the inventory management and let them know about the out of stock items. The agent is able to receive images and voice commands, and it can process them. Based on that, it generates an update for the inventory and then checks for out of stock items. If there is no out of stock item, then we basically come back to the idle mode. But if there is any out of stock item, we're gonna send an email to the inventory manager. Before we start building our agent, we need to have some receipt images. So we will be able to test our agent during the development process and see how it works with different sorts of receipt images. For the voice commands, I'm gonna use my own voice, so we don't need any dataset for the voice commands. But for the receipt images, we are going to use a dataset from Kaggle called OCR Receipts Text Detection Retail Dataset. So I'm gonna put the link of this dataset in the description. You can come and download the dataset for free. So after we downloaded this, we can start to build our project. To build our project, I'm gonna use UV. So I will say UV init inventory management bear Python 3.13. So the bear switch basically means don't create any extra folder or files for me. I prefer to create the files by myself. And I'm gonna use Python 3.30, but you're free to use any version that you want. After running this command, you're gonna have an inventory management project. Now I'm going to open the project in my IDE, which is PyCharm, and then I'm gonna do some configurations here before writing the code. So first we need to have a receipts folder that we put our receipt images there. So I just selected some images randomly from this dataset and put them here. And then we need an .env file. So I put a sample here for you to understand how should this .env file look like. You can just take a look at it here. So what you need is an API key from a model provider, which can be OpenAI, Anthropic, Google, or any other model that you want. You just need to insert the API key here. And for the second part of the video, we are going to need an email address, a password, and a SMT server, so we will be able to send emails. And the agent gonna use it to send emails for the out of stock items. All right, so I'm gonna copy my env file to the project, which contains my actual information, my API keys, email and password and other stuff. And now we are good to start writing our code. So I'm gonna add some libraries here. I'm gonna add Streamlit and Langchain for now. So Streamlit is used for creating the UI, and Langchain is the library we're going to use for creating our agent. I'm gonna start by creating the UI. So I will create a UI.py file, close this, and here I'm going to start by creating our page. So for running your page, you can say uv run streamlit run ui.py. After you run this, a new page gonna show up in your browser, which is empty for now, but we are going to build our UI here step by step, and it's gonna be filled. So I'm going to say import streamlit as st, and then st.title inventory manager version 1, and st.set page config page title inventory manager. And layout, we want a centered layout. So here, when I save the file, you can see that some messages come here that says file change. You can rerun it, which updates the page. The other thing you can do is to just come here and activate the auto run. So anytime you make a change in the page, you don't need to update the page manually. So here you can see the title has updated. Then I save it, and it will update again. All right. So we are going to need 3 tabs. So each tab is designed to handle one part of the job of the agent. So first tab is for uploading the receipt images. Second tab is for voice. And the third tab just shows an inventory data. So we can see what's going on and we can do some manual updates to that if our agent made some mistakes. So I'm going to say tab 1, tab 2, tab 3 is equal to st.tabs and then create a list here. And then I'm going to say receipt upload, the title of the first tab. Second one will be voice update. And the third one gonna be inventory like this. And just to be more beautiful, I'm gonna just paste some emojis here. You can skip this part if you don't like, but I personally just like to make it a bit more appealing for me. So I just copy paste these emojis and just put them here. Now that we have the tabs, we can switch between them. We are going to start by building the third one first. Why? Because it's probably the simplest one. The inventory tab goal is to just show the inventory to us and also allow us to update it if needed. So the inventory in our project is simply an Excel file like this one. So I've created an inventory.excel file and just put some items in it just for you to understand the concept. So we're gonna have an item column, a category column, and a quantity column. And during the updates that happens to this inventory, new items might be added, some items might be removed, and the quantity of the items also might be updated. So what you should do is to now move this inventory Excel file into your project, and then we can start to work on the third tab. So we say with tab 3, if os.path.exists, and here I'm gonna say inventory path is equal to inventory.xlsx. Okay, here we can say if the inventory exists, we need to read the inventory information, right? So for that, I'm gonna install pandas, uv pandas. And now we can say data frame is equal to pd.read excel inventory path. So we read the file and we also define a search for our inventory so we will be able to search inside the inventory. So I will say st.text input search inventory, and for the placeholder I'm gonna say enter some words. I'm gonna close this so you'll be able to see it easier. And then we check if the search exists. Then we need to filter our data frame. So filtered data frame is data frame, and then data frame dot as type string. So we convert everything in the data frame as a strings to make it easier for us to do the filtering. Then we apply a function. The function is a lambda function that takes every row and then turns it into a string and search if it contains the search term. And it's not case sensitive. Then we just call any on that to see if any result is true, and we set the axis to 1. And if there was no search, the filtered data frame is simply is equal to the data frame itself. Okay, here we see an error called import error import open PyXL failed. So we also need to install this uv add open PyXL. And now, okay, let's have a look at our UI and see how it's going. So I just refreshed it and go to inventory, and now we have an inventory input. Great. Now we need to have an editor for our data, so we will be able to show the data and also edit that. So we say edit data frame is equal to Streamlit data editor. Then we pass our data. For the number of rows, we choose dynamic. That allows us to edit the data and add or remove the rows, which is exactly what we want. And then for the column config, we are going to say the quantity. For the quantity column, we want st.column config.number column alignment center. What it does is basically it just centers the numbers that are showing in the quantity column. Then here we're going to say if this button save inventory. Okay, before writing this, let's just save it and rerun and see what's going on. Okay, we can see here that we can see our data. The data is exactly the same as our Excel data, which is perfect. Here we can select some data, remove them, or we can insert some data. Like here I'm gonna say, for example, orange, it's a category of fruit, and the quantity is 3. So now we are going to work on the part that when we make an update to this data, we should also be able to save it. So for that, we are going to, I'm gonna paste the code that I was writing. So we are creating a button and check if it's clicked. I'm gonna also say the width of this is stretch. Okay, it just gives an error, but that's fine. Then we are going to say edited data frame dot to Excel. We're gonna save it in the same file. And index false. We don't want that. It creates an extra column for the index number for us. And then after that, we are going to actually show a message like inventory updated successfully. And if the button isn't clicked, or no, actually the else should be here. If the inventory doesn't exist, we are going to say inventory file not found. And then show the inventory pass. We save it. Then I'm gonna run it again. Come here. Very cool. We have the button. Also, remember that you can also change the theme if you want. So I prefer to go with the dark theme, but here you can also switch to the light or the system. So I come here and say, let's say I'm gonna add orange. And then the category is fruits, just fruit, and the quantity is 10. So I hit the save button. It says inventory updated successfully. And if I come here and open my inventory, you can see that I have an orange fruit 10 here. Perfect. If I refresh it, I'm gonna see the orange fruit 10 here. Great. That's pretty much everything we need for the inventory tab. Now we'll start to go to build the receipt upload tab. That's pretty much everything we need for the inventory tab. Now we are going to the first tab, which is receipt upload. Okay, let's write the code for the first tab. I come here and say with tab 1. So we need to create a file uploader to be able to upload our images, right? So I'm gonna say uploaded image is equal to st.file uploader, and then the label will be uploader receipt image, and the type that we are accepting is PNG, JPG, and JPEG. We can go to our first tab. We can see our receipt, upload receipt button. So The next thing that we're gonna do is to see if the image is uploaded. We want to show it, right? So I'm gonna say image is equal to image from the pil.image, import this, and then open uploaded image. Then to show that I am going to, I think, yeah, this import should be like this. Okay, I come here and say, create 3 columns. Then for the column sizes or ratios, I'm gonna use 1, 5, 1. And then I'm gonna say with column 2, the central column, show the image. So it will be image, caption, will be the uploaded image, the name, and then the width will be stretch. So I created 3 columns just to be able to put the image in the center of the page. It's a bit weird, but this is how Streamlit works right now for centering the stuff. You have to create images, you have to create the columns and then put the image that you want in that central column. So I'm gonna save it. Let's give it a try, see if it works. So I'm gonna come to the receipts folder, get an image and drag it here. Yes, it works and it shows the receipt image here for me. Perfect. I can try with other images just to make sure it works. Perfect. Cool. So now we are able to show the images, but the next important part is to actually be able to process the images. So I'm gonna come here and say, create a receipt button, receipt.button, and it will have the process receipt label and the width gonna be stretch. So you see the button here, and then I'm gonna say, if this receipt button clicked, create a spinner, processing the receipt, and then inside that, so basically we are going to have a try except block here. I'm gonna use exception to just get any exception for now. So this is the idea. We're gonna have a button. When we click the button, we are going to process the image using our LLMs, but if something goes wrong, we goes to the except block and show the error. So this part, I can say when an exception happens, just show an ST error. And for the error, use traceback.format.exe. And we need to import traceback. So this basically shows the exact error that happens. And now it's time to start to create our second file, which is agent.py. So I come here and say Python file agent. And here we're going to start to build some functions that we need to process the image. First things first, we need a function to create our agent for us. So I'm gonna say create inventory agent. It will receive a model, which by default I'm gonna use GPT 5.4 Nano. But as I said before, you can use any model that you want. So we are going to define some tools for our agent, which is now empty. Then we are going to have a prompt. So I already have written the prompt for you. So you can just copy paste here the prompt. I'm gonna put the link for you. But what basically it says is that it first says that you're an inventory management agent. It says some important points like quantity means number of physical units, price is the monetary cost, never confuse price with quantity. So you might ask, how did I come with this prompt? So I did a lot of testings and saw the possible errors that an agent can make during processing the images and voice and all the other stuffs. And based on that, I tailored this prompt. So if you see, I've put like never confuse price with quantity because I've seen that the LLMs or our models confuse that. So that's why I added this to our prompt. Then I also added some notes like, okay, if the quantity is not explicitly written, assume the quantity as 1. And then I give some example to it. So like milk $4.99, your output should be something like item is milk, quantity is 1, and the price is $4.99. And I also put some not to do's for our prompt, which is like don't extract total, subtotal, taxes, payment lines, and stuff like that, because we don't need them basically. So after having the prompt, we can start to say model with config equal to chat open AI. So for this, we need to actually install a package, I guess, which is Langchain OpenAI. So I'm going to say UV add Langchain OpenAI. And let me try again, chat OpenAI. Yeah, now we can use it. So here I'm going to say model equal to model and temperature equal to 0, because basically I don't want my model to be very creative. We are not going to create a story or a creative image. So I just want the data to be extracted as they are. I don't want any creativity added to that. That's why I set the temperature to 0. And then I'm going to say indent expected. What's going on here? Okay, it should be like this. Then I'm going to say agent is equal to create agent, which should be imported from Langchain. So I'm going to say from Langchain dot agents import create agent. Okay, create agent model will be the model with config, and then tools will be tools, which is an empty array for now, and the system prompt will be prompt, and that's it for now. So we are going to return the agent at the end. So this function basically creates an agent for us and returns it. Now we go back to our UI, and basically we are going to create the agent and add it to our page. But the way Streamlit works is that every time a change or an event happens on the page, it will refresh everything and run the whole code from top to the bottom. But we want our agent to just be persisted in the session. We don't want to create it every time. For that, we are going to use something called session state. So I'm going to say if agent not in st.session state, then st.session state.agent is equal to create inventory agent. So basically, just check if the agent exists in the session state, it just passed, but if it doesn't exist, it creates the agent and just assigns it to that agent. Okay, here says missing credentials, please pass on API key or other stuff. That's because we never actually loaded our credentials, I guess. So we go back to our agent, and then here I'm gonna say, okay, first let's add .env, then I'm going to say load.env and pass the address for the env file. Let's rerun this, and now it works fine. Okay, now that we have an agent, we can work on the receipt part. So I'm gonna go to the agent.py, and here I start by creating a send receipt function. This function receives an agent, which is our agent. I'm gonna just put the type here because it helps me in the type annotation and just makes my life easier in autocomplete, but you don't have to add this. So I'm gonna say image bytes is image.getValue. So basically we get the bytes representation of an image, and then we convert it to base 64, or better saying, we encode it in base 64. This is what we need when we want to send multimedia data like images, videos, or audio through the web to our model. We have to always convert it to base 64. So I'm going to say img base 64 is equal to base64.b64 encode and img bytes, and then we decode it to UTF-8. The reason we decode it to UTF-8 is that we need to convert it to text to be able to transfer it through the web. So UTF-8 actually just converts the bytes into the string, so you can transfer it. All right. So now we are going to send a request to our agent and ask him to actually convert the image to receipt, right? So for that, it's better to write a message or a text for the LLM so it understands better what's the concept. So I'm going to say multimodal message is equal to human message, and then the content will be, so I'm gonna just copy paste this part to save some time. So we have a text message here, which basically explains what is the image that we are uploading here. It's a shopping receipt, and then gives some important hints again. And here we put the image and we put the base64 representation. And at the end, we are going to say return agent.invoke, and then messages is multimodal message. So I'm going to explain more about the text that I put here shortly. But for now, let's just test our model and see how it works. I go back to UI. And here I'm going to say receipt OCR is send receipt. And then we use the st session state.agent as the agent and uploaded image as the image. So let's save it, refresh it just one time, and see if actually we can probably just say st.write receipt OCR to see what's the output. Then I'm going to upload the receipt here and click on the process receipt. Shows the spinner and then shows the message. Perfect. So the first message here is the message that we sent to the LLM, so we can just pass it. And it's a very, very long message. So actually what I can do is probably something better. I'm going to say write messages and then the last one. Let's send it again. Perfect. So here you can see that we got the response. The content is like a JSON that says action is insert, item is the item name, kettle, sea salt, pot chip, which is exactly what you can see here. We have braided something and chef plate meal. So let's see how good is our model. We have braided something and then chef plate meal. Perfect. And it also detects the quantities correctly. The quantity here was 2, and perfect. It seems that it works, and we can basically process a receipt. All right. The next step is to move from this string output of our agent to a more structured output. This is because LLMs are not deterministic, meaning that they can generate a different result every time you call a request to them. So because of that, we are going to define an structured output and force the LLM to only output the result in that format. We go to agent file, and then I'm going to go to the top part here and say an inventory update is a base model. We use base model from Pydantic. Then we are going to say every inventory update has 3 things: action, item, actually 4 things: action, item, category, and quantity. So an action can be the literal of insert, delete, increase, and decrease. So we define basically these four actions as all possible actions that an inventory update can have, right? So you can insert an item to the inventory, you can delete an item, or you can increase or decrease the quantity. And then I'm going to say we have item, which is a string, which is just the item name. And then we're going to have category, which is from category type that we are going to define. And then we have also quantity, which can be int or float. For the category, I'm going to just define it here to be easier. So I'm going to say, I'm going to copy paste it. So category is basically just a literal of these items. Basically, we are forcing our agent to produce the category into one of these categories. And also, if it was not into these categories, it should just use the other category. All right. So then what we have, actually, I'm going to create another class and say inventory updates, which is a base model, inherits from the base model, and then has updates inside it, which is a list of inventory update. Basically, we define it like this because it's possible that through a voice command or through a receipt, we need to make multiple updates to our inventory. So we are going to have a list of updates. And then I'm going to add some descriptions and examples to each of these parts: action, item, category, quantity, and updates, just to make it easier for our model to understand the idea behind each of these properties. So I'm gonna, for the action, I'm going to copy paste this and also import field from Pydantic. Yeah, very good. So basically describes what is an action and describes when you should choose each of them, like insert, delete, increase, decrease. And for the item, I am going to paste it here like this, which basically describes what is an item. It encourages the model to use single forms for the names, like apple instead of apples, banana instead of bananas, and other stuff, and give some examples. For the category, we are going to have just some description, and for the quantity, we are going to have some description and some examples. And lastly, for the updates, I am going to also add some descriptions to help the agent understand the concept behind it better. Perfect. Now we have inventory update type defined. So what we can do is that we can come back to create inventory agent and go to the, where was it? Okay, here. Here we can say structured, is response format is equal to inventory updates. We're gonna save this. We're gonna run the local user interface again, and then I am going to submit a receipt. All right, so we are going to have the same string here, but we should also have something called, if I'm not wrong, structured output. Let me see if I can find it here. Okay, it's because here we should actually, instead of printing these, print structured output. And I'm going to save it, run it again, and then send the receipt again. Okay, we got an error, key error, structured output. Okay. Oh, I'm sorry. Actually, it should be structured response. My bad, guys. So we run this, process receipt again, and yeah, here we go. We have an updates list, which inside it has inventory update objects, and you can see everything is much more structured. We have the action, which is insert. Usually for when you upload a receipt, the action gonna be insert because you're just going to insert new items. Unless you have the same items in the inventory, then in that case, it might be increased. It will be increased actually. And then we have the item name, the category, snacks, which is perfect because it's able to choose the correct category automatically by itself. We don't need to hard code anything. And we have all the items. We can actually try for a few more receipts just to see what's going on. So this is a huge receipt actually. Perfect. So the next part is to create the update inventory function. Imagine that we have created the updates here. Now we want to actually apply these updates to our inventory. So for that, we are going to actually create a new function. We are going to create update inventory function, which receives the updates and then process the update. However, before writing this function, we are going to write 3 utility functions that actually helps us in implementing this. I'm going to explain each of them one by one and why they are needed. So the first utility function that we are going to build is called normalize item name. So I will say def normalize item name. It receives a name as a string and returns a string. So we are trying to normalize the item names. So all of them actually refer to the same thing. For example, after a reset is get processed, we know that apple and apples might refer to the same thing, or apple with uh, lowercase letters and apple with uppercase letters might refer to the same thing. So we don't need to have 2 different rows for that. That's why we need to normalize the item names. So I am going to say name is equal to name dot lower dot strip, and then I'm going to basically be lowercase the name and remove the empty spaces, and then I'm going to say AZ09 replace it with space and do it for the name. So I'm gonna import RE as well. And the next thing we do is to say, so this line basically means remove everything that is not A to Z or 0 to 9, any special character, it just replace it with empty space. And then we are going to say, if you found like multiple spaces, just replace them by one space. So if you have something like, let's say, apple juice, it will replace it by apple juice, something like that. And then we are going to return the name. Perfect. So now we have a function that we can use to normalize the item names before we insert the items into the inventory and also before we look up for an item inside the inventory. The second utility function that we are going to write is called find canonical item name. It receives the inventory path, proposed name, and threshold, which by default we can just set it to 80. So what does this function do? This function, when we try to insert some item to the inventory, it just first tries to understand if an item similar to that name already exists in the inventory. If that item exists, we don't need to create a new row. You might say, wasn't the normalized item name enough? And the answer is no, because sometimes LLMs might output the names in different ways that they refer to the same thing, but they are slightly different even after the normalization. So because of that, we are doing some fuzzy searching, fuzzy matching, sorry, to understand if two strings are actually similar to each other or not. If they are so much similar, probably they are just referring to the same item. So we are going to use this same item name for just updating that row. That's the idea. So here I'm going to say first read the Excel file, inventory pass, and then I'm going to say existing items will be data frame item dot as type string, and then convert it to a list. Next step, I'm going to say normalize lookup is equal to normalize item name existing for existing in existing items. So basically for every item that exists, we are going to create a dictionary that here we have the normalized item name, and then here we just have the normal name. Then we are going to say match is equal to. So here, before we continue, we need to install a new library, which is called RapidFuzz. It's used for fuzzy matching two strings. So it's just easy to install. So we are going to say uv add RapidFuzz. And now we can continue. So here we're going to say process. First, we need to actually import process from RapidFuzz. I'm gonna also import fuzz, which I use later. So I'm gonna come here and say process that match extract one. So we are just going to look for one. Then we pass normalize item name, proposed name, and then normalized lookup dot keys, and then scorer fuzz dot ratio. I don't know why I put two parentheses here, but yeah, now it should be good. Then we say if there was no match, just return proposed name dot strip dot lower. But if there was a match, then matched normalized name dot strip the score is equal to match. And then if the score was more than the threshold, then we are going to return normalized lookup match normalized name, and then convert it to strip, then lower. And other than this, we are just going to again return the same thing, propose.strip.lower. Perfect. Now that we are done with the naming things, we are going to actually write a utility function called isValidInventory item. So what we are going to do here is to just check if that item is a valid item to be inserted into the inventory. We're going to basically do some checks. So I'm gonna say item is item strip that lower, and then I'm going to say, let's just copy from here. So I have a blocked item names here, which includes items like total, subtotal, tags, cash, card. So we know that when we see these things in the inventory update, it should be probably a mistake from the model through the OCR process. So we don't want to add them actually into the inventory. We are simply ignoring them. So we go back to our function and say if item in blocked item names, return false. If re.match r plus d is EA, LB, KG, G, OZ, and then the item, return false. So here we basically check if the quantity or unit lines include something like pound, kilogram, gram, and things like that. That's also an invalid input for our quantity column, so we're gonna return false. The next thing we are going to check is to actually check if @ sign is in the item. sometimes OCRs return that, so we don't need it. And then the last thing is to check if an item name is made mostly from the non-string characters, like digits, space, and other special keywords. So if we had something like this, we can consider it that it's not a name, so we are going to return false. In any other case, we are going to return true. Now we are ready to go back to our inventory function and actually write it. So here I'm going to say df is equal to pd.readExcel inventory path, and then while we process the items, we are also going to collect the items that are going to be out of stock after the updates. So we keep them and later we can send an email. So I'm gonna say 0 stock items is an empty list. So for update, in updates, item will be find canonical item name, inventory path, update.item, and then the threshold will be 80. You can play with this threshold and see which one works best for you, but for me the threshold 18 was the one that actually giving me good results. So I'm gonna say if not valid inventory item, so we just continue, we basically ignore that update. But other than that, we are going to save the quantity in update.quantity and then say exists is equal to any fuzz dot ratio. We are doing a fuzzy string matching item with the existing dot lower. If the score was more than 85, so existing is also a loop in the item dot values. So if we were able to find any item, then we know that that item exists. And now we say if update that action is equal to insert, then if exists, we are going to actually df.log df item .str.lower equal to item, and then find the quantity column and just add the quantity to it. So we are basically updating the quantity if that item exists. If it doesn't exist, then we are going to create a new row which contains item, category, and quantity. And then we are going to say df.log len df new row. Basically, we append the row to the bottom of the list. So this is the update for the insert action. Now we are going to do the same for the other actions. So if the action was delete, we are going to say df is equal to df item and then string dot lower and not equal to item. Basically, we are filtering out every item that is not equal to our item. Whatever remains is the inventory after deleting that item. Very simple. Now we are going to say, let me put some spaces here. Now we are going to say if update action was increase, again, check if it exists. We are going to actually copy paste the code, is the same code. And if it doesn't exist, we are going to create the new row. So the code for insert and increase is pretty much the same. I could just write them down in one block, but I decided to put it separately. So if later we plan to do some changes, it would be easier for us. And then the last action that we are going to implement is decrease. If action was decrease, then again, we are going to check if it exists. Then if it exists, we are going to just decrease the quantity and Also, we are going to make sure that we're not going to have negative quantities in our inventory. So for that, I'm going to say df log df item str lower is equal to item and then quantity. Let me put some spaces here. Okay, is equal to df log, copy the same thing, dot clip lower is equal to 0. Basically, we clip the quantities to 0. And then we are going to say, let's check the current quantity after the updates. So we are going to say matching rows is equal to df item dot str dot lower equal to item. And then if not matching rows dot empty, if it wasn't empty, we are going to say current quantities is equal to matching rows dot I like 0 and then quantity. So if the current quantity was 0, we are going to append it to our list. And then we also update our Excel index false. So here we are going to have some code for sending email, which we will write it later. But for now, this is pretty much all we need. So I'm going back to my UI, then I'm going to the tab 1, let's go to our try. Here, after we process the image and convert it to text, we are going to say update inventory, receipt OCR, structured response, and dot updates. And let's try it. Let's see how it works. So I am going to just attach one receipt, then say process receipt. So here we have the update. So we add an item bananas with the quantity 1. And if I come here, I can see that I have a new item here. Let's also put some timing here so we can kind of measure how long it takes for our agent to respond. So I'm going to say start time is equal to time.perf counter. And then I am going to say after here, I'm going to say elapsed time is equal to time.perf counter minus start time. And then I am going to replace this message here with another message. Like actually, I'm not gonna replace it, but I'm just gonna add one additional image here. One additional message here, which says receipt processed successfully in some seconds. Let's run it again. Call the function again, and now you can see it processed in 2 seconds. Perfect. And our inventory also got updated. All right, so the next part is to actually work on the voice update tab, the second tab. So let's go to the second tab. I am going to come here and say with tab 2, the audio is equal to st.audio input, record your voice message. And then I'm going to say audio button is equal to st.button process voice command. And the weight, of course, is stretch. And if we had any audio recorded, we are first check if the audio button is pressed. And then I'm going to say create a spinner, processing the voice command. And let's say try. So we're gonna have the same thing. We're gonna have a try except block here. And I can actually copy this part from here. If there was any error, we are going to show it. Other than that, we are needing a function to process the voice, similar to what we did for the image. So I come here and say def send voice. It needs an agent and also needs a voice. So we get the voice. Actually, before writing it down, let's just have a look at our agent and see how it works. Okay, it says that try is empty, so I'm gonna just put pass here and run it. So now we have a voice update here that you can actually record the voice. So I'm going to say, for example, here, decrease 3 from the bananas. Then I can just have it recorded and I can play it. Decrease 3 from the bananas. Perfect. Let's go back to the send voice code. Now I'm going to say audio bytes is equal to voice.getValue. And then we are going to create a MIME type, which is gonna be get attr voice type. We try to see if it has a type, then we get it from there. If it was not, then we are just going to put audio wave. Then for the file name, I just create a fake name. I just call it voice.wave. Then I'm going to create a client with OpenAI. And I think we have to add OpenAI. I'm not really sure yet, but let's see. Oh, we have it. So we don't need to install. So we are going to say transcription is equal to client.audio.transcriptions.create. And then for the model, for the transcription, we are going to use GPT-4o mini transcribe. And for the file, we are going to just pass file name, audio bytes, and MIME type. Then we just need to create a human message, which I'm gonna copy paste from here. Basically, it says that you have to process this command and just produce the transcription. Then we are going to say return agent.invoke message. Actually, it should be messages. Perfect. So let's try our method and see if it works. So I'm gonna go back to UI and say voice transcript is equal to send voice st.session_state.agent and then the audio. And then we can say st.write voice transcript structured response. All right. Let's process this voice. And perfect. It understands that the command was decreasing 3 items from the banana. Perfect. I can try it one more time and say, for example, add 25 apples to the inventory. Then send the command. Perfect. Increase apple by 25. So now we are just going to actually just search, say start time is equal to perf counter, and then here say elapsed time is equal to time.perf counter minus start time. And then say st.success voice command processed successfully in seconds. Okay. What we need to do now is to, after we got the transcript, we should actually call the update inventory function. So we update the inventory. We are going to send structured response here dot updates and see how it works. I'm gonna refresh it. Then let's talk about the bread. So we have 3 breads here. Let's go to the voice update and say increase the breads in the inventory by 8. Let's see if it works and it updates the inventory. So it couldn't find any update actually. Let's try it again. Increase the bread by 8. Okay, it understood that we are saying increase the bread by 8. Then let's go to the inventory. Then we can see that the inventory updated and the bread items is actually 11. Great. I personally like this a lot because it's very interesting, like the way you can communicate and update the inventory just by sending a voice message or just scanning a receipt. That's perfect. So all of these automations are perfect, but at the same time, we should always provide the way to intervene the work of an agent and kind of make some necessary changes if needed. So here we have that through this interactive data representation. So if for any reason my agent made a mistake, I can come here and, for example, update the 11 to 12. And then I will hit save. And then if I refresh, go to inventory, that value is updated. Or I can simply, for example, delete some items. But make sure that you hit the save button, because if you don't hit the save button, no change gonna happen, not gonna persist it in the inventory. All right, now we are going to improve our agent a little bit by introducing a tool that allows the agent to look up the inventory whenever it wants. So it just results in better updates because the agent can look at the inventory items and search for the things and then decide about what type of updates it needs to produce. So we are going to create a new function. I will create it right after the create inventory agent. Here, I'm going to say tool, just because it's a tool. So we are going to use the tool decorator. And then I'm going to say lookup inventory query. So it receives a query and returns a string. We are going to put a docstring here. Since this is a tool, it's important to have a docstring so the agent can understand actually what is this tool and what it does. And then we are going to just read the Excel file and create a results and say for row in df.iterRows item is equal to string row item and then score fuzz ratio. So we receive the query for lookup and then we are going to do the fuzzy string matching again. Here we are going to say query.lower.strip and then the item.lower.strip. So we get the score by matching the items, and then if the score was more than, let's say, 75, add it to the results. So we add it to the result. We are going to add a dictionary with information. So it's going to be row item category. It's going to be row.get category, and the default value would be none if there was no category. And then for the quantity, we are going to say row quantity, and for the similarity, we have a score. And then here we are going to say if there was no results, just return no matching inventory item found for this add the query. And in the normal case that we have some result, we are just going to return the string form of that result. And then we are going to add lookup inventory to the tools. So this is just helps the agent to make better decisions when producing the updates. Let's see if we can give it a try. So I'm going to refresh this and I will come here So we can see that we have, for example, 10 orange here in the inventory. But in the voice, I'm going to say 10 oranges and see if it can understand that these orange and oranges are the same and should be updated the same row, or it creates a new row. So I'm gonna say increase oranges count by 10. Let's process. You can see that it says increase orange by 10. Even though we said oranges in our voice, but it understands that it should refer to orange, and that's perfect. All right, now we are going to implement the last part, which is sending emails to the inventory manager whenever some items get out of stock. For that, we actually did the main work in the update inventory where we stored the zero stock items. So we just need to have the function for sending the email. I'm just going to copy paste the function because it's not so much related to the main concept of our video. It's basically a utility function. So I'm just going to copy paste here and then explain it to you. So the send email is going to receive a list of receiver emails, a subject, and a body. So we have some data stored in our environment variables like email address, password, and server and port. And for the Gmail, after some new updates, you are no longer allowed to use your own personal password to log into an SMTP server like this and send emails. So for that, what you have to do is to go to myaccount.google.com. Then you have to search here for app passwords. Then go to this part and it asks you to log in. So after you log in, you have the form to create a new app. So you're going to create a new app, for example, test 2, and then it will give you a password. And you have to use this password actually as your email password. Just make sure that you are removing these spaces between the 4 characters. So there should be no spaces in the password. And after doing that, you are good to go. Just put it in the email password environment variable. And then what we do is to first just make sure we have the email address and the password. And then we are going to create a message, set the from, to, and subject. And then we are going to create a server and actually instantiate a server and then log into that server with our credentials. And finally, we are going to send the email. So let's go back to our update inventory function and update the part that we actually have to send the email. So I come here and I am going to say if we had zero stock items and we had some receiver emails, which I'm gonna define now. So for now, I can come here and simply say receiver emails is equal to, I'm gonna use a temporary service called tempmail just to have a temporary email to test. So you can use your own email if you want. Then I add it here and go back to my code and say body is equal to the following inventory items reached zero stock. Something like this. And then for item in zero stock items, just add them to the body like this and send email. So receiver emails is going to be receiver emails, and then subject is going to be something like inventory alerts. Items out of stock. And body is equal to body. Let's try it and see if it works. So let's go back to our code and say, okay, we have milk and the quantity is 1. So I'm going to say reduce the milk by 1 and then send it. Okay, it says reduce the milk by 1. and it hasn't updated here actually. So let's see what's going on. Oh, we have a misspelling here. It should be decrease. Perfect. Let's try again. Decrease the milk by 1. Okay. The milk is decreased by 1. And let's look at the inbox. Yes, we received an email that says the following inventory items reach 0 stock and has the milk. Perfect. So that's pretty much about it. Enjoy your inventory manager agent. You can just put any receipt that you want and just scan it in like a few seconds and interact with your inventory by voice updates. And that's it. Thank you so much. See you in the next videos.